Hello, everyone. My name is Vivaan Echambadi, and today I'm here to present to you my research on market sentiment analysis using LLMs and the RAG pipeline with mentorship and guidance from Mohit Manohar. So, who am I? I'm a junior at Issaquah High School in Washington State. I'm very passionate about AI, large language models, and data science. Outside the classroom, I'm a basketball player at the varsity level, and I compete in AAU. I'm also actively involved in my community, volunteering and mentoring youth to make a positive difference. And I'm excited to share more about my experiences and interests with you all here today. So, what is the main research question we are trying to solve? How well can advanced machine learning models predict stock price movement, and what role does market sentiment play in these predictions? Here's the agenda for today. Start off with kind of an introduction of market sentiment analysis, then moving on to some related research in the field, then the methodology in the research, the results in the analysis, and finally the conclusion. So, what is market sentiment analysis? Market sentiment analysis is a powerful tool for understanding how public opinion and emotions are impacting financial markets. First, we're going to look at some technical approaches used in modern sentiment analysis, including NLPs, machine learning, and big data analytics. Next, we will examine how market sentiment correlates with actual stock price movements and the impact and the implications this has for investors and traders. Finally, we will discuss some of the key challenges and opportunities ahead as sentiment analysis continues to evolve and become more sophisticated. Now, some related research in the field. Traditionally, sentiment analysis relies on lexicons and task-specific NLP models, which do have some scalability limitations. Some other limitations of NLP models include the understanding of nuances in financial terminology and the amount of time needed in updating the model's dictionary base. Large language models, on the other hand, such as Finbert, leverage pre-trained knowledge to perform well in financial contexts, even outperforming the NLPs. Now, the retrieval augmented generation pipeline used in this study integrates vector retrieval with large language models to enhance the prediction accuracy. And going back to kind of the main research question, can we prove that sentiment serves as a driving force that predicts stock price fluctuation? Now, for the methodology. So this flowchart here really outlines the key steps in our systems design process that I will go more in depth into in just a second here, but really starting off at a holistic level and then diving down into the detailed design of each single component and then finally getting it all together. So what were the components? The first step in this process was the data collection and preparation. A web scraper that I implemented in Python collected financial news articles to analyze their impact on stock price movements. Collected data included 34,000 plus news articles from reputable sources and historical stock prices from 2021 to 2024. News articles were then mapped to stock tickers using entity recognition, ensuring relevance to the respective companies. Social sentiment was initially explored, but it was excluded due to some limitations and inconsistent labeling in the analysis. So here is kind of an overview of the key data sources and variables I used in the financial news sentiment project here. And this covers some of the different data points I collected, including stock tickers, news article titles, publication dates, stock prices, and the sentiment analysis results from the Finbert model. So this was kind of a good look at what all I've collected and what all I've tested on. Now, the next step in the process, the text preprocessing. This was a very important step to make sure the model can be as accurate as possible. The key steps in text preprocessing are tokenization, stop word removal, normalization, lemmatization, and vector embedding. Now, vector embedding was the more nuanced one, and I did this because the retrieval augmented generation pipeline takes in the vectors as the input. So first you have to convert the text to vectors, and then from there input that into the model. Now, going to some feature representation here, vector embeddings actually capture the semantic meaning of words and phrases by representing them in a multidimensional vector space. This allows us to understand the relationships between different concepts and ideas in the news articles. Then for an efficient retrieval, the FEISS database enhances processing speed by optimizing vector similarity searches for large data sets. And finally, how can we get the text to be represented for the model to understand? The bag of words technique and TF-IDF representations improve the sentiment analysis by quantifying the text features. Now, this is a model overview here. So the RAG pipeline in this model uses contextual financial news articles to improve the accuracy of sentiment analysis for the stock price prediction. It starts off with a stock performance query, which a retriever processes to find the relevant documents. Then those documents are then sent to Finbert to analyze the retrieved documents and label them as positive, negative, or neutral sentiment. The sentiment outputs are used to then predict the next day's stock price movements, and then they are output for the user. So the results of the analysis here. The volatility and sentiment, we can see three distinct levels of volatility from the different sentiments, negative, neutral, and positive. So negative sentiment shows the highest volatility percentage at 5.47%, indicating high market uncertainty and risk. Now, the neutral sentiment has a moderate market fluctuation around 3.02%. And the positive sentiment actually displays the lowest volatility, surprisingly, at 2.76%, suggesting a more stable and confident market environment when we get positive sentiment in the market. Now, this data can really help us understand how investor sentiment drives market dynamics and volatility. Analyzing these patterns can inform our investment strategies and risk management approaches. Now going here to some more detailed analysis using standard deviation. Standard deviation is a measure of volatility. It indicates how much a stock's price tends to fluctuate around its average. So we can see here that Tesla and Nvidia have the highest standard deviations, meaning their stock experiences the wildest swings when they get a positive or negative sentiment. In contrast, Microsoft has the lowest standard deviation, indicating its stock price is more stable. So the higher volatility of Tesla and Nvidia really does reflect the significant sentiment swings for those companies, with investors frequently changing their views. So this information can be useful for investors to understand the risk profile and to understand what they are seeing in the real world and how to apply that to their investments and manage their portfolios accordingly. Now, the impact of stock sentiment on next day stock prices. This is where you can really see how sentiment impacts stock prices in the short term. The analysis here is that the negative sentiment shows a 1.29% average decrease in next day stock prices. When you go to neutral, it's very stable pretty much. Stocks with a neutral sentiment label showed minimal changes, averaging a 0.08% movement the next day. Then, positively labeled stocks saw an average 0.29% increase in next day price. So this data really demonstrates the significant impact that sentiment can have on short-term stock price fluctuations and how it can be used for users to understand when to invest in these stocks. Now, understanding the regression model, how do we contextualize the results that we have? So we use the linear regression analysis, which examines the relationship between sentiment score and next day stock prices. Using this, we calculated the R squared value, which is 0.01, indicating that sentiment scores only explain 1% of the variance in stock prices. The remaining 99% of variance is driven by other market factors, such as market conditions, sector trends, and macro indicators. To improve the model's predictive accuracy in the future, we probably need to incorporate additional variables beyond just sentiment scores. I think we have to understand here, sentiment is just one piece of a very complex market puzzle, and a more comprehensive approach is really required for an effective stock prediction model. Now, conclusion. The summary of our findings. So we found that advanced machine learning models show promise for stock price prediction, but sentiment analysis alone only explains about 1% of stock price variance. Interestingly, negative sentiment has a stronger impact than positive sentiment. Looking ahead, I really do believe that incorporating real-time data and more advanced LLM techniques could enhance the accuracy of these models. While sentiment analysis does have limited predictive power on its own, when you look at, in a macro setting with these hedge funds, it can really be a valuable input to them to gain an edge. And then also for us, if we want to maximize our profits in the market, it can be used as a valuable input as part of a more comprehensive market analysis approach. Now, any questions?
Oops, I realize I'm on mute still. Thank you so much for sharing. I invite everybody who's in the audience to share questions in the chat. So I have my own question. So it's interesting that you mentioned that social was something that you explored, maybe scraping, but then, chose not to. And I wonder, does that have anything to do with the news being expert sentiment and maybe social being novice sentiment? And what do you think would have happened if you had included it?
I think there would definitely be some inconsistencies, seeing that, pretty much everyone has access to whether it be an X account or stock twits, right? There's a lot of places for people who, want to talk about the market. There would create some inconsistencies that if you look at the news and you look at, let's say, quarterly earnings, for example, right? Those are some of the more, they're literally numbers that the company is producing. And those really provide a more accurate sentiment, like where we can actually analyze it. And then also a lot of what people are saying in X or wherever in a more expert professional way, that can also be kind of dictated in the news articles that we get, right? Negative sentiment doesn't just happen from um, like in social media accounts. It can also happen from these different news articles. And I think, there's a good similarity there. And I just didn't want the data to get messed up in any kind of way because of social sentiment that exists out there. So that's why I kind of incorporated news data only.
Great answer. We have an audience question. Did you have a chance to test or examine the sentiment based on events like, DeepSeek to NVIDIA? Secondly, there are a lot of fake news out there. How do you think about cleansing noise in maybe some of those articles?
So to answer the first question, I didn't get a chance to do that. That would definitely be something in the future we'd examine where if there was a big macro thing that happened in the world, how do we kind of gauge what happens to the stock prices, what happens to the sentiment overall in a daily view? I think that would definitely be something to incorporate here in the future. And then, sorry, what was the second question?
Yes, the second question. There's a lot of fake news out there. So how would you go about, or how do you think about cleansing, the data for noise?
I think probably the most important part here would be kind of checking, and that's why the retrieval augmented generation pipeline is so important, is because that goes and it looks at, multiple other news article titles in the database, and it sees, okay, is this news article consistent with those that are in the pipeline? And then from there, if it is consistent and if it does, in a day by day, week by week timeline, if it does show consistencies there, then it sends it to Finberg to analyze. So that is kind of how we control for fake news.
Got it. So another question from the audience. What are your observations in regards to recent market fluctuations?
Recent market fluctuation, a lot of the times, whether it be political in the government, whether it be geopolitical issues, whether it be like an expansion recession that ends up happening, I think you can really see like the short-term stock price fluctuations. And that's really where, analyzing sentiment is important, right? I think in the long term, we can really see, unless the company nosedives, they are going to experience like growth, economic growth, and then stock market growth. So in the short term, that's really where you can use sentiment to figure out what your investments should be, and you can kind of use that sentiment to enhance your profits. So in the short term, that would be kind of where I'd look.
That brings up a question for me, actually. So, in your analysis, did you mention how far back in terms of the amount of time range that you worked with was?
Yes, so I started with 2020, early 2021, late 2020. That was kind of where the training data started from, and then the stock prices were kind of collected from there simultaneously with the news articles.
Fascinating. And did you notice any times of the year or, or major changes in the world that correlated with higher reactivity to positive and negative?
I would say quarterly earnings are the earnings calls, they are kind of pretty big. Like, it happened, I forget what year, I think it was 2022. I think I was looking at it, Microsoft released it, and then, their stock nosedived in the short term, right? Obviously, since then, Microsoft has grown, but I think you can really see with, even on a company level, once those earnings come out, then you can really see like in the short term, people are either very happy about it or they're, scared in the short term. So, and then I do think there was a pretty big push, just considering some of these world things, whether it be like push down or push up. You look at, let's say like over the summer, some things happened and like there can definitely be a lot of change there. So yeah, there were definitely some kind of macro issues that I saw, but dealing more with company by company, those earnings calls were really the biggest shifters.
Yeah, fascinating stuff. I'd be curious if, there's anything to like seasonality and things like, oh, I'm sure you can slice and dice it so many different ways. Super
Yeah.
cool stuff.